Yeah, guys, the net is very slow and it is not connecting. Can you hear me? Guys, can you hear me?
Yes, ma'am.
Net is slow here. Today there is net issue. Okay. After 10 minutes, I'll start the class. As I am logging with my mobile data. Okay.
Okay, ma'am.
Yeah, guys, good morning. Can you hear me? Guys, can you hear me? Guys, can you hear me? Hello, Sandeep, are you there? Hello,
Yes, ma'am.
can you hear me? Yeah,
Ma'am, you're barely audible.
right, let's start the class. So there is a little bit net issue. If there is any, you can't see the screen or you can't.
Ma'am, your voice isn't clear, ma'am.
Okay.
Lot of disturbance is coming.
Yeah, okay. So, as I'm telling you that we are having some net issues today, okay? Just
I'm still not audible, ma'am.
now, is it audible? Hello, is it audible?
Yes, ma'am.
Yes, ma'am.
Guys, is it audible?
Yes, ma'am.
Yeah, okay. Just tell me whether you can't see the screen or you can't hear me, just message me. Okay? Somewhat is disturbance over here. As we have discussed about find this algorithm. So find this algorithm, what it will do, it will find all the hypotheses. Okay. So for our data set. So whatever the hypothesis which we are getting with the finest algorithm, we are having different problems. Okay, in finest algorithm, just it will take only for the negative examples. It will be comparing with the negative examples. It will considering only negative examples, that is training examples, negative data. Okay, so that should not be there. It should consider all the examples, all the data which is present in the data set. Okay, so this is the main drawback with finest algorithm. To overcome that, there are more different algorithms like less than eliminate algorithm, candidate eliminate algorithm. So all these things. So in the previous class, I have discussed about list then eliminate algorithm. So before going to list then algorithm, just I want to tell you, we have discussed consistent hypothesis and Gaussian space. Okay. So consistent hypothesis. What is consistent hypothesis? Consistent hypothesis is nothing but whatever we are, what is the actual output and what is the predicted output. Both should be same. Then only we can say that that particular
hypothesis is consistent. Whatever the hypothesis which we are getting, that is consistent. So h of x is equal to c of x. Both should be same. Both should be equal. H of x is nothing but it is a hypothesis for a particular training example. C of x is nothing but it is the concept, that is observed data, observed output, whatever it is there in the data set. So both should be equal. So when we are applying any algorithm and we are getting hypothesis, and that should be equal to the observed data, that is nothing but predicted output and observed output, both should be equal here. Then only we can say the training data is, or hypothesis what we are getting, that is consistent. Okay. That I'll show you, then you can understand. So in this example, if you see, suppose H2 is a hypothesis in H. Okay. Sorry. If you see here, there are two tables. Okay, two tables are there. In that, the first table, it consists of H1. H1 is nothing but first hypothesis. We are getting a particular hypothesis with that particular data. And one more right side, one more table is there, that is H2. That we are getting second hypothesis. Okay, so they take these two hypotheses, H1 and H2. Now we have to see which particular hypothesis is consistent. Okay, so here D is a set of examples that consists of positive and negative. Okay, so here you can see in the table prediction. So play C of x. Play C of x is nothing but your actual output, what you have observed from the data. And the prediction is nothing but you have implemented the algorithm, and with that you have got the output here. That is H1 is one hypothesis. So I have not written the hypothesis. Some hypothesis is there. With that you have got some output. Now you have to see which one is consistent. Okay. So here this is this particular whatever the values which are there. This is D. D is nothing but set of examples with positive and negative. Positive and negative is nothing but yes and no. Whatever the observed data, C of x that is nothing but positive and negative, yes or no, with your data. And H is the set of rows. What is H? H is a capital H. Capital H is the hypothesis which you will be getting by these all set of rows. Okay. And C is the concept to learn. C is nothing but your concept. C of x is nothing but your concept that you have to tell whether the observed data is correct or not by applying some algorithm. Okay. So if you see here in the first row, sunny, hot, and your observed is no, you cannot play. Okay, and your prediction also no. That means your observed and your prediction both are same. That is nothing but it is consistent. The first row is consistent. In the same way, second row, rainy, cool. So my aim is to play game. Play some game. Okay. So by using this data, whether I can play or not, that I can predict. Okay. So second row is rainy, cool. So what will happen? I can play game. Rainy, cool, I can play game, and my prediction is also yes. So that is nothing but it is consistent. In the same way, third row, rainy, it is mild, I cannot play, and my prediction is also no. So this is consistent. Sunny, cool, play, yes, and my prediction is also yes. So it is consistent. Now if you see in H2, take the first row, sunny, hot, and my observed data is no, and my prediction is yes. That means it is not inconsistent. That is not consistent. It is inconsistent. In the same way, take the second row, rainy, cool. My observed is yes, and my prediction is yes. It is consistent. Third row, rainy, mild, no. It is consistent. Sunny, cool, yes, no. That is, it is not consistent. As my first row is not consistent with the data, so I can say whatever the hypothesis which I am getting, H2 hypothesis, that is not consistent. That is inconsistent. So what I have to do? I have to eliminate it. So these are all can be done by using different algorithms like general to specific boundary, specific to general boundary, that is candidate elimination algorithm. So we will be using candidate elimination algorithm. Hello? Shivani in a class number, Mali koncham. Okay, so this is about consistent and inconsistent. So whatever the data which is there, when we are predicting any hypothesis, when we are getting any hypothesis, then what we have to do here is whether that particular hypothesis is consistent or not. That we have to prove. Then only we can say whatever the hypothesis which we are getting, that gives us accurate result. Okay. Okay, so this is about consistent hypothesis. So consistent hypothesis means for all x consistent hypothesis for training set D, for all the pairs of x, C of x element of D, that is nothing but h of x is equal to C of x. So then we can say that particular hypothesis is consistent. So h of x is nothing but hypothesis, C of x is nothing but it is the concept, that is target data, that is observed data. Okay, so if both are equal, then we can say that particular hypothesis is consistent. Okay, so there are many algorithms to find the consistent or inconsistent data with version space. Okay, so here what is version space? Version space is nothing but it is with respect to hypothesis space H and training examples D is a subset of all the hypotheses from H consistent with D. So what we are doing, whatever the data set which is there, to that we are finding all the hypotheses, and then we will see whether all the hypothesis is present will suit for our model or system or not, that is present in the version space or not. Okay, so if any particular hypothesis is not consistent, then we will remove that hypothesis from the version space. Okay, so version space లో ఏముంటుంది, ఏదైతే డేటా సెట్ కి మనం అన్ని హైపోథసిస్ కనుక్కుంటామో ఆ అన్ని హైపోథసిస్ వర్షన్ స్పేస్ లో ఉంటాయి. After including all the hypotheses into version space, what we will do, we will eliminate the hypothesis which is not consistent. Okay, so after removing all the consistent inconsistent hypothesis from the version space. Whatever the hypotheses which are present, those are related to version space here. The consistent data or the consistent hypothesis will related to version space. Inconsistent will be removed. Okay. So first of all, what we will do, we will consider all the hypotheses, either it is consistent or inconsistent. After implementing some algorithm, we will remove the inconsistent hypothesis from the version space. Okay. So this can be done by using less than eliminate algorithm. So less than eliminate algorithm is nothing but, first of all, the first step is version space. Version space is nothing but it is the list of all hypotheses. Many hypotheses కనుక్కోవాలి. For each training example, x comma c of x, x అనేది training example అంటే one instance. C of x is nothing but either it is 1 or 0, yes or no, positive or negative. So that, okay, for each instance ki అది yes unda, for each instance ki no unda. So that is nothing but x comma c of x. Remove from version space any hypothesis h for which h of x is not equal to c of x. What we have to do? We have to remove the hypothesis which is inconsistent. Okay. So this can be done by using less than eliminate algorithm. So what we have to do? Some data set is there. First of all, we have to find the instance space. Instance space is nothing but a combination of data which is present in the data set. AX is one set, AY is one set, BX is one set, BY is one set. So here what is the data? You are having A comma B is one data, X comma Y is one data. Now with this, what you have to do? You have to find the instance space. So finding the instance space, you will be getting 4 examples. After that, you have to find the hypothesis space. Okay. So these are all nothing but hypothesis space. How many hypothesis space you will be getting? 16. How you will get? By implementing question mark and phi to your data. Okay. So A, X is one set, A, Y is one set, A and phi is one set, A and comma is one set. Phi is nothing but it is the specific hypothesis. To specify that specific hypothesis, phi is used. Question mark is used to represent the general data. Okay. Now next, B comma X is one set, B comma Y is one set. In the same way, B comma phi and B comma question mark. So likewise, you will be getting 16 hypotheses. That is, these are different hypothesis space which you are getting. Now, what you have to do? You have to find the whether these hypotheses are semantically distinct hypotheses or not. To that, what you have to do? Whatever the phi symbol sets are there, that you will be considering with only one. That is phi comma phi. Okay. So with that, how many you will be getting? 10 semantically distinct hypotheses you will get. After that, what you have to do? You have to see whether all the semantically hypotheses are consistent or not. That you have to check. Okay. Now take the data, that is F1 and F2 are two attributes, AX and AY are the instances related to F1 and F2, and your target data is yes and NDS. Okay, so this is your data. Now compare all these semantically hypotheses with this particular data. Whatever the data which you are writing, this is called as version space. What are the hypotheses which you are getting? Those all hypotheses are related to version space. Okay. Now compare the first one, A comma X. Compare with A comma X. It is positive. Why? Because it is matched with AA XX. In the same way, compare A comma X with second instance, second row also, AY. it is not matching. Okay, so eliminate this. In the same way, a comma y, it is not matching with the instance, so eliminate this. A comma question mark, a matches with a and question mark will matches with x. Why? Because in case of question mark, you can take x or y, any one. In the same way, compare a comma question mark with the second instance a y. A matches with a and question mark will matches with y. So you will remain it. In the same way, b comma x, it will not match. B comma y not match. B comma question mark not matches. Question mark x will match with first row, but it will not match with the second row, so you will eliminate that. Question mark y will not match the first. Question mark will matches with both the rows, so keep it. Phi, it always does not match with any row, so you will eliminate it. Now, what are the consistent hypotheses which you are getting? That is a comma question mark and question mark comma question mark. So these are the two consistent hypotheses which you are getting with all the hypotheses which are there in the version space. So this will be done by using list then eliminate algorithm. Okay, so now you will be representing the version space with different ways. That is, you will be using different algorithms here. What are the different algorithms? That is general to specific direction, specific to general direction, and a candidate elimination algorithm. Okay. So for getting the version space, that is nothing but whatever the hypotheses which are consistent. For getting the version space, we will be applying the algorithms like candidate eliminate algorithm. Okay. Next, general to specific algorithm or specific to general. These are implemented in workspace to get the accurate hypothesis. Whatever the hypothesis which are there, that will be getting by using these algorithms. Okay. So before going to next algorithm, that is candidate eliminate algorithm. So why we are using all these things? So that to overcome the findest problems, you will be implementing candidate elimination algorithm here. Okay. So here to get version space, it contains subset of all the hypotheses. So to find out here, it follows less than algorithm. Okay, and in less than algorithm also you will not get all the hypotheses. Again, what you are doing, you are implementing one more algorithm, that is candidate elimination algorithm. Okay. So why we are using candidate elimination algorithm here? So why we are using means, first of all, understand about specific to general direction. So here you will see specific to general direction. So the specific boundary S of version space is a set of its maximally specific members consistent with D. It summarizes the positive examples. Anything more specific will fail to cover a positive training experience. So specific boundary is used only for positive examples, and the general boundary is used only for negative examples. అంటే ఏంటి అని అంటే స్పెసిఫిక్ బౌండరీ అనేది ఓన్లీ పాజిటివ్ ఎగ్జాంపుల్స్, అంటే ఎస్ ఉన్న వాటికి మాత్రమే డేటా సెట్లో ఏదైతే మీ అబ్జర్వ్ డేటాలో ఎస్ 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 ఏదైతే ఉందో దానికి మాత్రమే మీరు స్పెసిఫిక్ బౌండరీ అప్లై చేయొచ్చు. బట్ ఇన్ కేస్ ఆఫ్ జనరల్ బౌండరీ, బట్ ఇన్ కేస్ ఆఫ్ నెగిటివ్ ఎగ్జాంపుల్స్, నో నో నో, వాట్ ఎవర్ ద అవుట్పుట్ విచ్ ఇస్ దేర్, నో నో. సో హియర్ యూ కెన్ సీ ఇక్కడ చూడండి డేటా సెట్లో నో ఉంది, ఎస్ ఉంది. సో దట్ ఈస్ నథింగ్ బట్ ఫర్ నో యూ విల్ బి యూజింగ్ general boundary, for yes you will be using specific boundary. So this should not be done, both you have to use. For that purpose we will be using candidate elimination algorithm. Okay, so before going to candidate elimination algorithm, I'll give you example for specific to general direction and general boundary. స్పెసిఫిక్ టు జనరల్ డైరెక్షన్ అంటే ఏంటి అని అంటే, if a person want to learn tennis, okay, so he want to learn tennis. So if you want to learn tennis, what are the general things he want? What he want? That is, he want shoes, bat, uniform. So likewise. So what are all these? These are called as general. Okay. So here why we are saying general? General, why we are saying means bat can be anything. It can bat. You can buy bat whether it can be high or low. Means ఎక్కువ ఉండొచ్చు తక్కువ ఉండొచ్చు bat cost. Shoes కూడా ఎక్కువ ఉండొచ్చు తక్కువ ఉండొచ్చు. So in this way, what you are doing here, you are generalizing the things. So this is general boundary. That is nothing but you are giving some description to the data. Okay. And one more thing, if you take your class, my class was 60 members. Anybody who is getting greater than 40, those students are pass. This is nothing but general. Getting 40, pass. This is general. Okay. Now, if marks greater than or equal to 40 and marks less than 60, what it is saying, it is specific. That is nothing but it is specifying something. It is specific. The condition is specific. Why it is specific? It comes under first class. More specific. We are saying about more specific to the data. So it is general to specific. What we are doing here, we are converting this general to specific. So class lo under pass avuchu. Can become more specific. What we want? We want more specific. So what we are doing here, we are giving different conditions to the data. So with that, what is happening? The data which is there, that has been become more specific. Okay. So this is general to specific. Specific ante ఏంటంటే, it can data will be there, will not be there. But in case of general, data will be there. Either it can be this or that. True, I mean, bat or the sky is there. Sky can be cloudy, windy, rainy. So likewise. So what it is? This is general data. Okay. So there may be so many instances which does not qualify minimum qualifying rules. Those are all general boundary data. Okay. So specific, I think you have understood about what is specific and what is general. Okay. So now, so whatever the data set which is present, okay. Guys, is it clear? What is general and what is specific? So here every member of the Gaussian space lies between specific general boundary. Okay, so whatever every member of the Gaussian space lies within specific and general boundary. So whatever the data which is there, whatever the hypothesis which we will get, that lies between specific and general boundary. The data, anything, any data, anything it can be, that lies between specific and general boundary. So here, Gaussian space of H comma D. What is H? H is the hypothesis. Vs is nothing but Gaussian space. D is nothing but data. So H such that H belongs to capital H. Whatever the hypothesis which we will get for individual row, that belongs to capital H. Okay, final hypothesis. Whatever the individual hypothesis which is there, that belongs to the final capital. Okay, final hypothesis. Individual hypothesis belongs to the final hypothesis. Whatever the hypotheses which are there, those belongs to the final hypothesis. There exists S belongs to S, there exists G belongs to G. S belongs to S is nothing but specific for a particular row and specific for the total data, and G is nothing but general for a particular row and G is nothing but for the total data. Capital G is the total general data, S is the capital S is the total specific data. That is nothing but G greater than or equal to H greater than or equal to S. If this condition satisfies, that is nothing but what are the hypothesis which we are getting, that belongs to the Gaussian space. Okay, so if you see the example, then you can know what the theorem is saying about the finding for the hypothesis here. Okay. Yeah guys, so today 2 to 4 we are having lab. We will do 1 or 2 experiments and I'll explain candidate elimination algorithm, and third chapter I'll start. Okay, so if you are having any doubts regarding anything, just come forward. Okay, we will have discussion in the lab session. And Sandeep, can you share me the attendance, today's attendance?
Okay, ma'am.
Will you take a screenshot of it?
Yes, ma'am.
Don't leave. Okay, and send me immediately, Sandeep. After taking the screenshot, just inform me or inform your friends too. Then they can leave.
Okay, ma'am.